Beloyarsk nuclear power plant opened the epoch of large nuclear power for our country. This is the only nuclear power plant in Russia with different types of the reactors situated on the same site. It consists of 3 power units. The first power unit with the AMB-100 thermoneutron reactor generated over 8 billion kilowatt-hours of the electric power for 17 years. The second power unit of more power, named AMB-200, served for 21 years and generated more than 22 billion kilowatt-hours. At present, the first phase of the Beloyarsk NPP is under decommissioning. Known as the Large Peaceful Atom, it has fairly seen service at Beloyarsk nuclear power plant. The commissioning of the first units can be said to have played the key role in the development of the entire nuclear power industry in Russia. The operating experience from these installations can be hardly underestimated. In fact, for a long time, Beloyarsk NPP has been a basis, a school for training the specialists of our industry. The technologies acquired at these reactors were successfully introduced at a larger scale while developing the nuclear power industry. The only fast neutron reactor power unit of 600 megawatt commercial power in the world has been operating at Beloyarsk NPP already for more than 30 years. By the technical parameters, this reactor meets all the present-day reliability and safety requirements and features the property of inherent safety. The latter is characterized by the following: the intrinsic proofness of the reactor core due to the natural physical properties, the negative reactivity effect in all the operating conditions, the absence of xenon poisoning, and the high stability of the neutron field. At the design stage, it has been already clear that the BN600 power unit number 3 will be characterized by the properties of the natural inherent self-proofness. Namely, these are feedbacks. All the reactivity effects at all the power levels are negative. Moreover, the power density field is very stable and uniform. The pressure inside the reactor vessel is also nearly natural. That is to say, the vessel is unloaded. Graphically, the operation of the fast reactor looks like the following. Power unit number 3 consists of the sodium-cooled BN600 reactor, staged steam generators, and turbo generator sets from which the thermal and electrical power is delivered to consumers. The reactor vessel is a cylindrical tank. The main vessel is enclosed within a guard vessel, precluding the sodium leak from the reactor into the pit if the integrity is lost. The heat transfer system consists of 3 parallel heat transfer loops independent of each other, each in turn consisting of 3 consecutive circuits. The coolant of the primary and secondary circuits of each loop is a liquid metal, namely sodium. The coolant of the tertiary circuit is water and steam. The presence of the 3-circuit heat transfer system allows it to preclude the release of radioactive matters from the primary circuit into the water-steam circuit. In addition to everything, the high thermal inertia of the coolant, which is sodium, and its low corrosion activity with respect to the structural materials can be mentioned. All the above mentioned confirms that the BN600 reactor features the high degree of safety. The rated lifetime of the power unit as planned by designer was up to 2010. Since 2003, a large scope of work has been carried out to provide for the lifetime extension of power unit number 3. The work on safety improvement, on power unit efficiency enhancement has been fulfilled. The work resulted in obtaining the license for the additional operation of power unit number 3. The license was obtained for operation up to 2020. As a result of the completed innovations, the power unit corresponds to all the present-day world concepts of the NPP safety provision. So in the course of the upgrade, the emergency reactor console, initially unforeseen by the designer, but required by present-day norms and rules, was installed and put into operation at the Beloyarsk NPP. The establishment of the emergency control console means the possibility of taking the reactors subcritical, keeping it subcritical for a long time and removing the decay heat. From here, the situation can be monitored actually in every room of the unit as well. The establishment of the unit control console is one of the most important steps towards the unit safety provision. The operator can monitor the position of the control rods. If worst comes to worst, take the reactor subcritical using the scram key. One of the most important reactor components is a refueling system. It provides for the loading of the fresh fuel subassemblies and control rods into the reactor and their unloading after irradiation, as well as the reshuffling and turning of the subassemblies in the core. During the upgrade, the new refueling control system was developed at Beloyarsk NPP, which allowed the accuracy and reliability of the operations performed with the nuclear fuel to be improved, the refueling process to be automated, and the potential possibility of operators' wrong actions to be ruled out. In total, the upgrade program cost Beloyarsk NPP nearly 8 billion rubles. It is impossible to enumerate all the upgrades. Hereinafter, we indicate only some innovation phases. So the second independent emergency protection set was developed at Beloyarsk NPP Power Unit 3. For the time being, we are in the area of the second emergency protection set, which fulfills the function of the reactor emergency shutdown when the parameters reach the predetermined levels. For several recent years at Beloyarsk NPP, 2 existing emergency power supply channels have been retrofitted, and the third channel has been developed. Saying of the redundant power supply systems, independent of each other, now there are 3 of them. The equipment and the power unit buildings have been brought to the aseismic condition. The new system of the automatic seismic protection ensures the instantaneous power unit shutdown in case of an earthquake of grade 5 or more. The dedicated ventilation system for the air cleaning during possible sodium burning uses a multi-cyclone collector has been developed. The additional system of the emergency reactor heat removal on the basis of the air heat exchanger, which will decrease the probability of the severe consequences during the potential accidents by another order, is under development. The system of the radiation monitoring of Beloyarsk NPP Power Unit 3 underwent considerable innovation modifications as well. The installed state-of-the-art digital instrumentation ensures complete and instantaneous information on the radiation situation of the entire NPP site, which arrives at the radiation monitoring room. The individual radiation monitoring is an important part of the personal safety culture of the nuclear power plant personnel. The development of the engineering solutions verified in the BN600 reactor, reliably operating for more than 3 decades, is implemented in the Beloyarsk NPP BN800 reactor under construction. The erection of the fast neutron reactor of the new generation will allow a number of the most important tasks for both the Ural region and Russian nuclear industry to be solved. Today, the state-of-the-art technologies allow it to make the nuclear power plant operation stable, safe for the human being and environment, and as efficient as possible.